Hello everyone, I am Dattatranikam. Welcome you all on our channel eFunda for new day, new topic. And our today's topic is little different from electrical discipline point of view. And our today's topic is designing hazardous area classification drawings part 24D. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to various topics of engineering, for which a separate playlist is created and published on our channel eFunda. Also, if you are new to our channel, then don't forget to subscribe to our channel and press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, eFunda team has created a membership option. You have to just click join button and get the details of each membership and their benefits for your kind information. And so let's begin with our today's topic, that is designing hazardous area classification HAC drawing part 24D. Understanding the basic of HAC. Designing hazardous area classification, that is HAC drawing, is a critical process for ensuring the safety of electrical installations in environment where there is a risk of a fire or explosion due to the flammable material. One can refer to the picture of a petrol pump scheme, which is generic and everyone aware of this operation. For that we have used this picture. Your breakdown of the process is quite comprehensive, so we need to understand and expand our understanding on key steps and consideration for better clarity, as the vehicle coming which brings the fuel is indicated with a zone 0, and the tank where the fuel is stored is shown as a 0 in a red color, where the source from which the valve is getting open, or from the digital meter or a pump station from which the nozzle is being used to transfer the fuel into the car or respective vehicles, is classified under zone 1, and outside atmosphere about this facility of a petrol pump is considered as a zone 2. So the detailed classification we will see on our video. Also, for this particular topic we have already created video on understanding or hazardous area classification, for which you can use our I button to refer our video. What is a hazardous area? A hazardous area is an environment where there are enough quantities of a flammable material such as gases, vapors, liquid or dust to pose a potential or explosion risk. These areas can exist in various industries such as oil, gas, chemical processing, pharmaceutical and food manufacturing unit, which we have seen in one of the figures of a petrol pump example. Also, one can refer to the second picture where the classification markings of a zone 1, zone 0 and zone 2 are done, where the tanks are indicated with various different color. The nomenclature and identification of this color will also see into detail during our this video. So why is classification are important in case of these facilities? Hazardous area classification is essential because it determines the type of electrical equipment and installations that can be safely used in those environments. The classification ensures that electrical systems do not act as an ignition source and that could trigger an explosion or a fire. The incorrect equipment selection or installation can lead to catastrophic failures, which can prove or it can lead to the fire or explosion at the defined facility. Key factor to consider for preparation of a hazardous area classification. One can refer to the picture where some of the shadings are done with a different color pattern. That is the drawing of a hazardous area classification. This is overall plant layout is being used for showing the hash marking, which is a hazardous area classification. So key factor to consider for this, one can refer to the second picture. First, gathering information about hazardous substances. Second, identify hazards and a potential risk. Third, evaluating the level of a risk. Fourth, implementing control measure. Fifth, review and updating the assessment. So in line with that, we'll see some of the key factors. First is the flammable material. Understand the physical and chemical properties of such type of a material, such as a flash point, boiling point, vapor pressure and auto ignition temperature. For example, a substance with a low flash point might create a hazardous atmosphere even at the lower temperature. So it is very important to understand. Second, operating conditions. This includes factors such as the temperature variation, pressure level, ventilation system and the frequency of material releases. Understanding the operating environment will help you to classify the areas accurately, which help you to choose the right type of equipment. Third, potential ignition source. These could range from static discharges to the electrical equipment like motor, switches and lighting system. Identifying all possible source of ignition is an essential to ensure that they are either eliminated or mitigated in hazardous area classification. Last one, standards and regulations. Standards like NEC Article 500, ICEX, ETEX and NFPA provides a clear guidelines on selection of electrical equipment, wiring method and installation requirement for hazardous locations. Compliance with these regulations is a mandatory process. This is how the key factor defined on this slide are very important while preparing the hack drawing. The classification process, for better understanding, one can refer to the table where courtesy by DECRA for providing hazardous area classification process, starting with a team assembling. Second, flammability data compilation. Third, building and equipment layout. Fourth, identification of a potential release sources. Fifth, estimation of a leakage or a release duration. Sixth, ventilation effectiveness evaluation. Seventh, ignitable mixture determination. Class at a division or a zone rating and necessary documentation. Further, last, that is class 1, zone 0, zone 20, class 2, zone 1, zone 21, class 3, zone 2, zone 22. In addition to this, one requires first process flow diagram, that is a PFD. This will show the overall process and help you to understand the flow of a material. Second, piping and instrumentation diagram, that is PNIDs. This provides more detailed information on the layout part and the connections of equipment, showing where the hazardous materials are being used or stored for necessary purpose. Third, equipment location plan. This helps identify where flammable materials are likely to present, especially around tank pumps or a reactor or a major equipment. This is how the process is being classified. Identifying potential hazardous area. Based on the gathered information, one must assess where the location material or hazardous material may be present in the dangerous concentration. This involves understanding of this location. One can refer to the layout various where the hazardous area marking is done with a different color so as to indicate the different zone, mainly pink color, sky blue color and dark blue color for various area marking. which involves identification of a storage tank, that is a fuel and a solvent, reaction vessel, that is a chemical reactor, pipelines or open drains, ventilation point, exhaust ducts, etc. This is how the identification is being done on the layout for clarity and identification purpose. Classifying the area. Once the potential hazardous area are identified, then it follows the classification. The classification could be zone, that is IEC ATEX, or division, that is NAC, depending on the location and the applicable standards. Mainly one can refer to the picture where the segregations are being done with respect to zones and the divisions. Zones classification IEC or ATEX. Zone 0, flammable atmosphere is present continuously or for the long period. Zone 1, flammable atmosphere is likely to occur under normal operating condition. Zone 2, flammable atmosphere is unlikely but may occur in rare circumstances such as during maintenance or failure event. Division classification, that is NAC. Division 1, flammable atmosphere is likely to exist under normal operating conditions. Division 2, flammable atmosphere is unlikely to exist but may occur due to malfunction or a rare event happened inside the plant. As you can see the example where fuel is carrying and the zone markings are being done, where zone 0, zone 1, zone 2 are provided and occurrence rate are also specified here. This is how the classification of area is very important after the identification stage while designing or preparing hazardous area classification design drawings. Documenting the classification and coordination with others. One must clearly mark the boundaries of each hazardous area on the drawing along with the classification. The drawing shall include many other parameters like equipment description and numbers, material handled and their properties, ignition point like flash point and ignition temperature, atmosphere group, that is gases and vapors, that is a group 2A, 2B, 2C, ventilation information if it affects the classification. For this easy reference, one can refer the hazardous area location marking where the flammable liquid is kept inside the tank. Then the key markings of the division 1 and division 2 are shown as we have seen previous examples of a zone. So these examples are related to division 1 and division 2, where vent and the hatch were the identified as a division 1 and the nozzle at which the vent is being shown are also shown in a red, whereas the other areas surrounding the tank and their vent points are considered as a division 2. This is how the marking is being done, and also the marking for equipment detail, that is the EX categories are mentioned where the explosion protection, type of a protection, gas group, temperature class, and then equipment protection levels are being defined. That is the example of ICX ratings and the equipment marking. Similarly, the close coordination with a process, a mechanical and a safety engineer is crucial to ensure that all the potential hazards are being identified correctly and accounted for. Then each input from maintenance personnel can also be valuable, especially when assessing the rare events or the changes in operating conditions. Moving on to key considerations for electrical design, where the impact decisions making equipment selections are being shown. Explosion proof equipment. For this understanding, one can refer to the below pictures where the markings are shown and the details of each type are shown for better understanding. That is a type of a protection for electrical equipment. First, explosion proof equipment. This equipment is designed to contain an internal explosion without igniting the surrounding atmosphere. Second, intrinsically safe equipment. This type of equipment limits the electrical energy to a level where ignition cannot occur. Increased safety. This equipment is designed with extra protection to prevent ignition source from forming itself. The classification and the protection techniques are being shown, and their X markings are shown in similar to the previous slide, where the details of a X marking and type of a protection equipment techniques are being shown and the types are mentioned. When the selecting equipment itself is a crucial to verify that the certified for these zones or a division classification. The equipment should appropriately mark with its certification code, that is example ETEX, ICEX, UL rating, etc. Now finally moving on to the installation method. The installation of a electrical equipment in hazardous area must follow specific guidelines to minimize the risk of ignition. We'll see one by one. First, cable entry system. This must be sealed to prevent the entry of gases or dust into the equipment. Wiring. Wiring in hazardous area should be enclosed in a flame-proof conduits or a tray that prevents any spark from escaping out. Third, grounding and bonding. Proper grounding is essential to prevent static discharges, which can be potential ignition source. The other consideration may include protection against mechanical damage, proper clearance and maintaining separation between the electrical and non-electrical equipment in hazardous area. Today in our video we have tried to cover the various parameters or a key consideration while preparing the hazardous area classification drawing, and hope this video help you to increase your understanding and enhance your capabilities for understanding hazardous area classification.
With this, we are concluding on our today's topic. Thanks for watching our channel eFunda, where you will get to know the fundamentals. So that is our tagline, get your fundamentals right, where we do identify the needs, then we evaluate the need, then define plan for a particular need, and then accordingly execute the plan. This is what we are creating our technical videos so that it will help every individual to get their fundamentals right. And if you are new to our channel, then subscribe to our channel and don't forget to press bell icon to get the latest notification on upload of our new video on our channel eFunda. Also, you can follow us on our Instagram page and do follow our Facebook page as well. So keep watching our channel eFunda for new day, new topic.